All right, welcome back to Stats. We've got a warm up here that's going to pretty much take us from start to finish on a regression problem. All right, the only thing this isn't really going to do is make us do one by hand. So what we have here is we have some data, and we have lean body mass in kilograms, and we have their metabolic rate, which is the amount of calories burned in 24 hours. And we're basically seeing, can we predict metabolic rate? All right, so we're trying to predict metabolic rate. This is going to be our response variable. And we're trying to predict it using lean body mass, which is going to be our explanatory variable. All right. So first things first, we're going to make a scatter plot of our data. So I've gone ahead and already typed all this information into L1 and L2. I'm going to go to y equals. I'm going to make sure that my stat plot is on. I'm going to make sure that I'm using the right lists. And then again, when I hit graph, if I don't get a great picture, I'm going to go to zoom 9, and then that's going to graph it for me. So again, I've got my sketch here. And when I make this sketch, I don't need it to be perfect, but I would like to see the axes labeled. So this is metabolic rate, and this is lean body mass. And then after that, try to give a reasonable approximation of what's showing up on your screen. But I don't need it like actually measured out or anything like that. All right, so there we go. Not perfect, but a pretty close approximation of what's happening on my screen. All right. Part B, find and write the regression line for this data below, then add it to your sketch above. All right. So I can go to stat calc. All right. Again, it doesn't matter which one I use. L1, L2, hit calculate. All right. That will give me my regression equation. And again, whether you use the stat one, whether you use the algebra one, doesn't matter to me. And our final equation would be y hat equals 201.16 plus 24.03x. All right, you're also welcome to use the actual variables of the problem to put it in more context. So you could say predicted rate equals 201.16 plus 24.03 times mass, but I'm fine with either of those. If I ask you to write a question, either one is good. And then it says add it to your sketch above. So you can just sort of sketch it through the center of points, or if you want to see what it looks like on the calculator, you can go to your regular y equals, put in the formula, 201.16 plus 24.03x. And then when you look at the graph, it'll draw that regression line through for you. All right. But it's pretty much kind of where we would expect it to be. It's more or less going through the center of our points there. All right. So again, this is our y hat equals 201.16 plus 24.03x. Explain in words what the slope of the regression line is telling us. So again, this is sort of just putting it into context, thinking about the story that this is saying. And the general idea is that an increase in lean body mass also increases metabolic rate. All right, that's kind of the big picture story that this equation is telling us. And then if we want to be more specific about it, each extra kilogram of lean body mass increases metabolic rate by 24 calories. If a new person has a lean body mass of 45 kilograms, what is their predicted metabolic rate? All right, so these are just the, plug it into the formula. So predicted rate is going to be the 201.16 plus the 24.03 times the 45 that we're plugging in. All right, and then that's just putting it in your calculator and saying 201.16 plus 24.03 times 45 and getting 1282.51. So predicted rate is going to be 1,282.51. And then if we're throwing a unit on that, metabolic rate is in calories. It's the amount of calories you're burning in a day. Okay. So we've got our scatter plot, we've got our regression line, there's our equation, there's our interpretation of what the equation is telling us, and then this is just showing us how to actually use it for prediction. All right, E, sketch a graph of the residual plot below. Describe what this graph tells about how well the line fits the data. All right, so let's go back to our calculator so that we can put this in. So to graph the residual plot, we're going to need to calculate the residuals. So that means going to stat edit. There's our X values. There's our actual Y values. We need to get our predicted values. So we're going to go up to L3. We're going to say 24.03 times L1 plus our y-intercept of 201.16. That's going to fill in L3 with all of our predictions. So again, we can just write here as a reminder, L3 equals 24.03 times L1 plus 201.16. All right, that's going to fill in all of our predicted values. Then if we want to know our residuals, we're going to go over to L4, and the residuals are actual minus predicted. So it's going to be L2 minus L3. Now we have all our residuals. So L4 is going to be L2 minus L3. And then our scatter plot is going to be on L1 and L4. All right, so if we go to our y equals, we have to switch this list here from L1 over to L4. We get our graph. Whoops, let's clear out our regression line. We can get rid of that now. And then if you're not seeing it, again, just go to Zoom 9, and there you should get your residual plot. So again, with these, the y-axis represents your residuals. The x-axis is your explanatory variable. So in this one, it's lean body mass. And then if we're sketching it here, we can get just a general picture of what's happening. All right, so we've got a general picture of what's happening there. And then how do we interpret this? All right, the residual plot shows no pattern. Which means the linear model is a good fit for our data. All right, so it's a little counterintuitive, but having no pattern is actually a good thing when we're making one of these residual plots. All right, which point has the largest residual and what is the residual? Explain what the value actually means. So we can do that by going back into our stat edit, and L4 has all our residuals. So we're just looking for whichever one is the largest. And we can see that it's right here. So 207.58. All right, now what point does that correspond to? We just have to go and look at L1 and L2. So it corresponds to a 42 grams of lean mass and 418 calories for the metabolic rate. Okay. So these right here are the actual values that we recorded in our data. All right, the predicted value is what we did in L3. So 1210.4 calories. This is the predicted value. All right, so again, this one's dealing with the metabolic rate. So the residual is actual minus predicted, or in our case, 207.58. All right, and what this value actually means is it means our prediction was 207.58 calories below the actual value. All right, so our prediction was below the actual value, which gave us a positive residual here. All right, what is the R squared value for your regression equation? Explain what this value means. All right, so again, the R squared, we have to go back and run the regression again. So that's where we get that. So L1, L2. Our R squared value equals 0.7682. Right. And what this value represents is the percent of variation in the data that is explained by our regression equation. So again, our regression equation is not going to be perfect, right? It's going to make mistakes because we're not considering everything. There's other things that go into metabolic rate other than just your lean body mass. Like your genetics probably play a role, but we're not looking at genetics. We're just looking at one factor, and that one factor can explain about 77% of the variation. All right, we can't explain all of the variation. We can't explain all of the changes because we're leaving things out. And if our model had more relevant factors, this would get closer and closer to 1. All right, the higher this number, the more accurate our model is, the better it's doing at making predictions. But to make more accurate predictions, you're going to have to include more factors. And we're only including one factor, and that one factor is able to explain 77% of the variation. So that's pretty good, but obviously it's not everything because we did leave out pieces. All right. So finally, calculate the standard deviation of the residuals. What does this number tell us? All right. So to calculate the standard deviation of the residuals, we're going to go to stat, calc. So let's write this down. Stat, calc. And then we're going to run one variable stats on L4. All right. So when we do that, one variable stats on L4, all right, we get all these values. Now, unfortunately, we cannot use this 90.65. right? And the reason for that is the standard deviation of residuals equals the square root of the sum of the residuals squared divided by n minus 2. All right, and the value that's showing up in your calculator uses n minus 1, so we cannot use this. Instead, we can use this. All right, this value right here on the calculator is equal to the sum of the squared residuals. All right, so that value is what we can use from the calculator. All right, so if we look at this here, that leaves us with the square root of 90403.8694 divided by n minus 2. N is 12. All right, so n is 12. So this is 12 minus 2. So basically, we're dividing that number by 10 and then taking the square root. So 90403.8694. I should have just moved the decimal, but oh well. Divide by 10, take the square root of that, and we end up with 95.08, we'll say. So this equals 95.08. All right, and the significance of that number is the average prediction error, right? Because that's what this is telling us. It's telling us the average prediction error. The average prediction error from our model is 95.08 calories. So that gives us the average prediction error coming from our model. All right. So again, this kind of brings us, all the way through everything we did in regression. All right. We're looking at scatter plots. We're looking at the actual equation. We're interpreting the equation. We're using the equation to make predictions. We're analyzing it via residual plot. We're calculating residuals. We're talking about R-squared values. We're talking about standard deviation of residuals. All right. So this is kind of a nice look back summary of everything that happened in that last unit there. All right. So again, I hope this was helpful. Let me know if you have any questions and we'll go from there.